Hello everyone, welcome to BYJU'S exam prep. So good evening. So एक बार सभी लोग बता देंगे my voice is clear or not? Audio video absolutely fine? Yes. So according to me it's good to go. ठीक है एक बार चेक कर लो सभी लोग और उसके बाद हम लोग स्टार्ट करते हैं आज का सेशन जिसमें हम लोग कम्युनिकेशन के कुछ इंपॉर्टेंट क्वेश्चन सॉल्व करेंगे ठीक है इट इज नॉट ओनली जस्ट बाय द textbook, but it is also important for your GATE examination. And it is the type of question, standard level of questions that I am covering over here, right? So quickly share the session with all of your friends, those who are interested to solve the questions of communication. Okay, so those who are interested to solve the questions of communication can join this session. It is important session because the digital communication I am going to cover. So usually the student face problem in the digital communication. So you guys can join for the digital communication, especially. Though you should join because it is the complete textbook questions. So you should obviously consider this. Yes, as your important one of your important sessions. So I have shared in all of my groups where I am present. So now you can also share the session with all of your friends. Then we will continue our discussion. So before starting the session, I would like to tell that I am having more than 13-year experience in the field of GATE and ESE. In the 2010, I started my journey and it is more than 13 years because it is 2023, almost November, it is running mid-November, you can say. And qualification is MTech from IIT Guwahati. Have done in the MTech in the signal processing, so I have good command over the signal system as well. So my area of expertise is signal systems or in communication, electromagnetic theory, advanced communication system (ICT), and I have also cracked the different PSU exams like Airport Authority of India, DRDO, Bharat Electronics Limited, and I have mentored more than lakhs of students. So to get my mentorship, you have to join this Telegram group. This is the Telegram group here. You can message me, you can tag me when you post any doubt in the group. This group is open for all. You can post your all the doubts related to the subjects, related to your preparation, that how you should revise, how can you utilize the test series, and how many test series you have to give, how many mock tests you have to give. Yes, Takesh, good evening and wish you happy Diwali and happy Dhanteras, Takesh. So good to see you after long time. I guess you are saying that you are my old student. So what are you doing nowadays? What are you doing nowadays means because you have already done read it from my side means you have studied my content. So now what you are doing nowadays? One more thing that you all should know that BYJU'S provide the scholarship test to the aspirants who are preparing for GATE and ESE, and for that, in every Saturday and Sunday we are open to take the scholarship test, and you can register yourself for this scholarship test. The link is given in the description. Okay, so you can go and check the description link, and everything which you are looking for, the link is given in the description, whether it is a Telegram group, whether it is a scholarship test, whether it is the app, BYJU'S exam prep app, you can directly download from the link given in the description. And if you suppose you want to register yourself for the uh, you want to register suppose yourself for the workshop, then also it is there. Okay, okay. ठीक है ताकेश एक्चुअली आई एम नॉट एबल टू रिकॉल कि आप से मेरी कब बात हुई थी व्हाट्सएप के थ्रू बट यस इफ ऑब्वियसली इफ यू आर सेइंग देन हम लोग की बात हुई होगी। थोड़ा सा मुझे क्लिक नहीं कर रहा है कि किस मैंने आपको क्या एग्जैक्टली exactly गाइड किया था एंड आपने क्या डिसीजन लिया, बट यस आप आए यहाँ पे और आप बताए कि आप स्टेट जेई में सेलेक्ट हो चुके हो, तो दैट्स ग्रेट। तो आप अपना धनतेरस सेलिब्रेट कर रहे होगे आज, है ना? एंड दिवाली भी आप बहुत अच्छे सेलिब्रेट करने वाले हो, मतलब आप प्रिपरेशन का कोई टेंशन नहीं होगा। मे बी हो सकता है कि आप और भी प्रिपरेशन कर रहे होगे आगे के लिए, बट आई एम नॉट श्योर। अगर आप और किसी एग्जाम की प्रिपरेशन कर रहे हो तो आप शेयर कर सकते हो, जैसे कि स्टेट जेई में हो आप, तो हो सकता है कि आप ट्राई कर रहे होगे एई के लिए, या आप ट्राई कर रहे होगे यूपीएससी टाइप के एग्जाम के लिए, तो आप वो भी बता सकते हो। दैट्स गुड टू सी कि आपका ऑलरेडी सिलेक्शन हो चुका है, तो मेनी मेनी कॉन्ग्रेचुलेशन फॉर दैट। ठीक है, तो सारे स्टूडेंट्स जो वर्कशॉप के लिए कंसिडर करना चाहते हैं वो लोग, सभी लोग इस वर्कशॉप के लिंक भी आपको डिस्क्रिप्शन में मिल जाएगा, वहां पे आप डाउनलोड कर सकते हैं और रजिस्टर कर सकते हैं। और एक इम्पॉर्टेंट चीज यहाँ पे है जो कि है स्कॉलरशिप टेस्ट, जो कि फ्री मॉक टेस्ट है। दिस इज नॉट स्कॉलरशिप टेस्ट, इट इज अ फ्री मॉक टेस्ट फॉर गेट 24 aspirants. So we are providing a free mock test for all the aspirants those who are preparing for gate 2024, and the syllabus and the timing and overall pattern, date, etc., everything is given in this particular slide, so you can take the screenshot। ठीक है राकेश, आप ट्राई करते रहो, है ना? अगर आप एक बार प्रीलिम्स निकाल दिए हो तो मुझे लगता है कि आप अगर कंटिन्यू करोगे अपनी ये प्रिपरेशन तो आप मेंस और इंटरव्यू भी कर लोगे। ठीक है, क्योंकि इम्पोर्टेंट ये है कि आप कंटिन्यूअसली प्रिपेयर करते रहो। जनरली हम गिव अप कर देते हैं अगर हमारे पास कोई और जॉब ऑलरेडी होती है, तो हमारा ऐसा होता है कि चलो ठीक है, जॉब तो है और आपके पास गवर्नमेंट जॉब है ऑलरेडी, तो हो सकता है कि आपको लगे कि ठीक है, मतलब चलेगा, अगर एक अटेम्प्ट किया, दो अटेम्प्ट किया तो चलेगा, अब इसके बाद नहीं हो रहा है तो। लेकिन आप ट्राई करते रहो, जितना आप मैक्सिमम आपके पास अटेम्प्ट है ना? अगर आप करोगे तो मुझे लगता है कि इसको कन्वर्ट किया जा सकता है ना? ये डबल ई ब्रांच के लिए सिलेबस है। सो दिस इज द सिलेबस फॉर ऑल इंडिया ओपन मॉक टेस्ट फॉर द इलेक्ट्रिकल इंजीनियरिंग। सो you can take again the screenshot of it, date and timing and result date, everything is mentioned। चलो, तो ये आपका फर्स्ट क्वेश्चन है, दिस इज योर फर्स्ट क्वेश्चन। सो आई एम गिविंग यू 3 6 minutes to solve this question because it is three part of this question. So for each part I am giving you 2 minutes. If you need more time then you can comment in the comment section, but yes, this is a good question। So the question says, a signal can be modeled as a low-pass stationary process x of t, whose PDF at any time t naught is given in figure. The bandwidth of this process is 5 kHz and it is desired to transmit it using a PCM system. If sampling is done at the Nyquist rate and a uniform quantizer with a 32 levels is employed, then what is the resulting signal to quantization noise ratio and what is the resulting bit rate? You have 2 minutes more. Yes. Last 1 minute. We have three part in this question. So in this question, as you can see that the PDF is given to us. So what is that PDF? This PDF is a triangular one that is having minus 2 to 2. Value is 1 by 2. This is of x. This is of f of x. Okay, this is the PDF of the message signal. Now, this message signal is having the bandwidth. So the bandwidth, you can say the maximum frequency is 5 kilohertz and is sampled. and is sampled at the Nyquist rate. Sampling is done at the Nyquist rate. So the Nyquist rate is Fs is equal to 2 Fm. So I can say that it is a 10 kilohertz or 10,000 samples per second. Now the uniform quantization is done. So uniform quantization. So in uniform quantization, how many levels they have used? So they are saying that there are 32 levels. So I can say that the number of bit will be log base to L. That means 5 bits. Okay. So what is the bit rate? The bit rate, if I want to calculate, as this is one part of the question, the bit rate is n into fs. So it is fs is 10, n is 5, so 50 kbps. So 50 kbps is the answer for the bit rate. Okay, 50 kbps is the answer for the bit rate. This is our first part. And in the first part also it has one part. Now we want to calculate signal to quantization noise ratio. So what is the quantization noise ratio? Okay, the quantization noise power first. Quantization noise power, because the uniform quantization is given, the quantization noise power is delta square by 12. So the quantization noise power is Vh minus Vl divided by number of levels. This is our delta. Delta square divided by 12. So the highest value is 2 and minus 2. So 2 minus of minus 2 whole square divided by number of levels. Number of level is 32 square into 12. So from here we will get the quantization noise power 2 plus 2 4. 4 square is 16. So we will get 16 and this is 2, so 24 into 32. Okay, this is 16, so 16 ones are 16 twos are 32, so 2 and 12 is 24 and 132 is left. Now this is first part of the quantization noise power. Now we want to calculate the signal power. So how will you calculate the signal power? The signal power is nothing but the mean square value of the random variable or PDF. Mean square value. So mean square value is nothing but mean square value of this is nothing but 2 times 0 to, let me write first, the mean square value means expected value of x square. So this is minus infinity to infinity x square of f of x dx. Because it is even, you can write 2 times of 0 say infinity x square and f of x dx. Because this f of x is in even. So this is 2 times of 0 to 2 x. What is this x? This is x square. What is this f of x? So we are calculating for the positive side. So this f of x is, slope is 1 by 4 with minus sign. So 1 by 4 x is the slope and intersection is plus 1 by 2. So it is minus x by 4 plus 1 by 2 and dx. Now 2 times, if I solve it, it is minus x to the power 4 by 4. Already 1 4 is there. Plus x cube by 3, which is 6 because already 1 is there. So it would be 2 times of minus of 16 divided by 16 plus 8 upon 6. And in 0, it will be 0. So it would be 4 upon 6, or you can say 2 by 3. Okay, it is 2 by 3 coming. So the signal power is 2 by 3. Now we wanted to calculate the signal to quantization noise ratio. So signal to quantization noise ratio is 2 upon 3 divided by 1 upon 24 into 32. So it will become 2 into 24 into 32 divided by 3. So 16 into 32. So it is 2 to the power 4, 2 to the power 5, 2 to the power 9. So it is coming as 512. So 512 is the signal to quantization noise ratio. Okay. And if I take the 10 log of 512, it is 27 dB. Okay, so this is our answer, 27 dB. This is the first part of the question. So we have to calculate these two things. First is bit rate we wanted to calculate. So we calculated it as a 50. And the signal to quantization noise ratio we wanted to calculate, which we calculated as 27. Got it? Anyone having any doubt in this part of this question? Anyone having any doubt in this part of the question? Okay. Now what is the second part? If the available bandwidth of the channel is 40 kilohertz, then what is the highest achievable signal to quantization noise ratio? So the maximum bandwidth available is channel bandwidth is 40, and which is RB by 2. That is the channel. So RB is equal to, we are getting 80 kbps now, and RB we said it is NFS. So what is the number of bit? 80 into 10 to the power 3. What was the sampling frequency? Sampling frequency was 10. So now the number of bit we have to use is 8. So if the number of bit is 8, what will be the change in overall? The overall calculation will be changed by the Nyquist quantization noise power. So quantization noise power was VH minus VL whole square divided by L square into 1 upon 12. So it is 2 minus of minus 2, that will remain same because the signal is having the same amplitude. But this will be now 2 to the power 16 because L square is 2 to the power n, and 2 to the power n becomes 2 to the power 2n, and n is 8. So it is 16 upon 12 into 1 upon 2 to the power 16. So it is 4 by 3. So I can say that the quantization noise power will be 4 upon 3 into 2 to the power 16. Signal power will remain same. So signal to quantization noise ratio will be 2 by 3 divided by 4 by 3 into 2 to the power 16. So this 3 and 3 will get cancelled, and we will get 2 to the power 16 divided by 2. So we are getting 2 to the power 15. So what is 2 to the power 15? 32768. So it is 32768. Now the signal to quantization noise ratio in dB is 10 log of 32768. So 10 log 32768 is 45.15. Check whether if you have any doubt in the question, in the question, especially in the calculation. Comment in the comment section if you have any doubt. What is the third part of this question? If instead of sampling at the Nyquist rate, we require a guard band of at least 2 kilohertz and the bandwidth of the channel is 40 kilohertz, then what is the highest? Now, guard band is there, it means that we are sampling with more than the sampling Nyquist rate, because the guard band is in the third part of the question. The guard band is at least 2, na? Yes. So guard band should be at least 2. So it should be greater than equal to 2 kilohertz. So what is the guard band? Guard band is Fs minus 2 Fm. It should be greater than 2 kilohertz. Okay. So the sampling frequency should be greater than equal to 2 plus 2 Fm. And Fm was 10. So it should be 12 kilohertz. So sampling frequency should be 12 kilohertz minimum. So minimum means the bit rate would be n into Fs. Okay, and the minimum bit rate we will get is number of bits. How many number of bits we will be using here? The signal to noise ratio, the bandwidth available is 40. Okay, so the bandwidth available is 40. So the RB is 80 and Fs is 12. Okay, so if I take this n is equal to 80 by 12, what will be the value? Fs should be greater than 12, right? So 80 upon 12 is 6.66. So we will take n equal to 7. If I take n equal to 7, suppose, then what will be the bit rate? The bit rate will become 84. So we need a at least bandwidth. Yes. So n should be 7. If I take n equal to 7, then Fs is equal to 2 Fm. Highest achievable bit rate we want. Fs should be 12, na? Yes, Fs should be greater than equal to 12. I am saying, so it should be, we have to set the number of this bit as a 6 value, because when you take the 7, it will cross this. We will set the n equal to 6, because if you will take n equal to 7, then it would be greater than this, and what we want here is the bandwidth available is 40. So when we take the 7, it will be greater than that, and the guard band should be more than 2 always. So the guard band will become, the guard band is Fs minus 2 Fm, right? It should be at least 2. That means it should be greater than equal to 2, we said. If I choose n equal to 7, then what will be my Fs? The Fs would be from here. If I choose n equal to 7, then Fs would be Rb by 7. Rb is 80, that is fixed. So 80 by 7. So 80 divided by 7, 80 divided by 7, we are getting 11.43. So if I take the sampling frequency 11.43, then what will happen? My guard band will become, Fs minus 2 Fm. So Fs is 11.43 minus 2 into 5. So it will be 1.43, which is less than 2 kilohertz. So that's why n equal to 7 cannot be considered. Because if I choose n equal to 6, suppose, if I choose n equal to 6, which I said, then Fs will be Rb upon 6. Rb is 80. So 80 upon 6 is 13.3 kilohertz. And when I calculate the guard band, this is Fs minus 2 Fm. So Fs is your 13.3 and Fm is your 10. Fm is 5, so 2 Fm is 10. 2 Fm is 10. So 13.3 minus 10 is 3.3. So this 3.3 is maintained, means it is greater than 2 kilohertz. So n equal to 7 we cannot consider, we have to consider n equal to 6, because n equal to 6 is giving us the required result. We need a guard band to be at least of 2 kilohertz. It can be greater than 2 kilohertz, but it cannot be less than 2 kilohertz. But when I choose n equal to 7, and because the available bandwidth is fixed, which is 40, so because of the available bandwidth, that is 40, the bandwidth is available bandwidth is 40, the bit rate is 80. So if the bit rate is fixed to 80 and my sampling frequency according to the number of bit, if I choose n equal to 7, then my sampling frequency is coming as 11.43 kilohertz and my guard band frequency is Fs minus 2 Fm. So if I calculate the guard band, then it is coming less than 2 kilohertz, which is violating our desired condition which is given in the question. So we will choose n equal to 6. So with the n equal to 6, if I calculate the quantization noise power, then it is Vh minus Vl whole square divided by L square into 12. So it was 2 minus of minus 2, that is the message signal amplitude, and L square is 2 to the power 12 because it was 6 into 12. So 1 upon, or you can say 4 by 3 into 2 to the power 12 we will get. So finally our answer would be signal to quantization noise ratio is 2 by 3 divided by 4 by 3 into 2 to the power 12. So it will become 2 to the power 11. So 2 to the power 11 means it is nothing but a 2048. So signal to quantization noise ratio in dB is 10 log of 2048. That is coming as 33.13 dB, 11 dB. Okay, so how many of you have got this? This is the first question that we solved, which is very good question. Okay, now answer this one. So solve this question. The stationary source is distributed according to the triangular PDF.
Just last 2 minutes. A stationary source is distributed according to the triangular PDF. This source is quantized using a 4-level uniform quantizer. Find the entropy. So we want to calculate the probability of each region. So let's try. Okay, so it is from minus half width is -2 and 2. Okay, and it is your x and this is your PDF which is f of x. F of x. And the height is also given as 1 by 2. 1 by 2 base is 4 and height is 1 by 2 base into height. Yeah, so base is 4, height is 1 by 2, so this is 1. Correct. So it means we have drawn that. Now it is saying that we are quantizing it in the 4 different region. Okay, it is given that when the input is between 1 to 2, the output is 1.5. So that means it is in the 1 to 2, output is 1.5. And when it is 0 to 1, it is 0.5 because it is uniform quantizer. So when it is in between 1 to 2, the output is 1.5. When it is 0 to 1,
the output is 0.5. When it is between -1 to 0, it is minus 0.5 and it is minus 1.5, right? Now, as you can see that the output is midpoint of the decision boundary and it is also given that it is a uniform quantization. So we want to calculate the probability of all this region because we want to calculate the entropy. So to calculate the entropy, we need the probability. So what is the value at point -1? So obviously it can be easily calculated if I write the equation of this f of x is the height, the slope is 1 by 2 is the height and base is 2, so 1 by 4. So minus x by 4 is the height, slope, and the intersection with the y-axis is 1 by 2. So that is for x equal to 0 to 2. Now we want x equal to 1. The value at x equal to 1 we are looking for. So minus 1 by 4 plus 1 by 2 equal to, that is nothing but 1 by 4. So the value at this point is 1 by 4. Now it is easy to calculate the probability. Now the probability of region 1 is same as the probability of region 4 because it is symmetrical PDF. So what is the probability? This is the range 1 to 2. So 1 by 2 base is 1 and height is 1 upon 4. So the probability will be 1 by 8. Probability of region R3 and R2. Probability of region R3 and R2. R2 and R3 we have 0 to 1. Okay, so this is a trapezoid, right? So it is a trapezoid. So it is a forming a trapezoid. This is the diagram. Okay, and this triangle. So you can directly write the trapezoidal formula or you can also use the triangular and rectangular. So 1 by 2 base even means 1 by 2 the addition of the parallel side, so which is 1 by 4 plus 1 by 2 and the distance between this is 1. So we are going to get 3 upon 8. 3 upon 8. So these two probabilities we are getting 1 by 8 and 3 by 8. Now we need to calculate the entropy. So the entropy of this is, we have the two probabilities as 1 by 8. So what is the formula for entropy? 1 by 8 log base to inverse of probability, and because we have to take the 1 by 8 two times, so it is multiplied with 2. Similarly, this is 3 by 8, 3 by 8 log base to 8 upon 3. Okay, and this is also 2 times. Now let's calculate this. So it is 6 upon 8. This can be directly written, but this is 3 upon 4 log base to 8 upon 3. 1.811. 1.811 bits. We are getting the entropy. So this is how you have to calculate. Okay. Anyone having any doubt in this part? So no need to solve the second part of, because the this is itself sufficient to solve. The second part is not that relevant for your gate point of view. Anyone having any doubt in this question? Okay, so you want me to solve the second part? Okay, fine. See, it is given that the output, let the second part of this question, let Where is the question? X cap is x minus quantization error. Means quantization error is x cap, let us say x minus q of x. Okay, so clearly we can see that because this is the quantization error. So clearly it can be seen that if x cap is greater than 0.5, if x cap is greater than 0.5, then the probability of x cap would be 0. And if the x cap is less than mod of x 0.5, okay, if mod of x cap is less than 0.5, then there are four solutions to the equation. Okay, there are four solutions of this, four solution of this equation. So let us say we are denoting it by x1, x2, x3, x4 and so on. So the PDF of x1, the PDF of x1 is x1 plus 2, okay, x1 plus 2 divided by 4. And what is x1? This is x minus 1.5 plus 2 divided by 4. This is x cap minus 1.5 plus 2 divided by 4. Similarly, fx2 is x2 plus 2 by 4. Fx2 is x2 plus 2 by 4. What is x1, x2? X1, x2 are nothing but the four solution of the equation. That is, I have written only. Okay, so the solution of x1 corresponds to minus 2 to minus 1, and the x2 is corresponding to minus 1 to 0. The x3 is corresponding to 0 to 1, and x4 is corresponding to 1 to 2. So this is x cap minus 0.5. This is the quantization error plus 2 divided by 4. F of x3 is x3 plus 2 divided by 4 minus x3 plus 2. So minus of x cap plus 0.5 plus 2 divided by 4, and f of x4 is minus of x4 plus 2 divided by 4. So minus of x minus x plus 1.5, x cap 1.5 plus 2 divided by 4. Okay. Now if you want to write the PDF, then in the what is the PDF? The PDF of x, and we have to differentiate and then add them. So when you take the differentiation, you will get 1 by 4. Okay, and when you add them together, finally, in this form, when you will write fx is summation over I equal to 1 to 4 f of x divided by the summation x minus qxi. Okay, fxi summation qxi, x minus qxi mod, and then add. Okay, so when you put all these values and when you add them together, you will get the 1. When you add all of these, you will get 1. X cap minus 1.5 plus 2 plus x cap minus 0.5 plus 2 minus x cap minus 0.5 plus 2 and minus x cap minus 1.5 plus 2 and whole divided by 4. So this x cap, this x cap, this x cap, this x cap will get cancelled, and this 2 plus 2 plus 2, this minus 2 will get also cancelled, and this will come as 1. Okay, so minus 1.5 is 3, 3 and 3 plus 1, this is 4. So this 4 and this 4 will get cancelled, and the 1 4 will be left. There are 4 times now this. So this 2 and 2 and this all negative values will get cancelled, and 2 plus 2 will become 4, and then 4 divided by 4 will become 1. So the PDF for this will be 1. Now answer this question. That's why I told that it is not relevant to the gate examination. So solve this one. A stationary random process has an autocorrelation function given by Rx is equal to a square by 2 e to the power minus mod tau cos omega naught tau, and it is known that the random process never exceeds 6 in magnitude. How many quantization levels? This random process never exceeds the 6 value. Okay. Come on, solve it fast. We have 2 minutes more, and there are only two parts of the question, so you can solve it in these 2 minutes also if you have good concept. How many quantization levels are required to guarantee a signal to quantization noise ratio of at least 60 dB? So 60 dB we have to maintain signal to quantization noise ratio. So you have 7 minutes more. Okay. Now, in this question, it is given that the autocorrelation of the random process is a square by tau, a square upon 2 e to the power minus mod tau 2 pi f naught t of the signal. So mean square value is nothing but the value at tau equal to 0, which is a square by 2. So the signal power is, the value of A is 6. So the signal power is 18 watt. Now we want to calculate the number of level where the signal to quantization noise ratio is given. Now which kind of quantization is done? It is not mentioned over here. So what we have to do, let's take the uniform quantization. Okay, let's take the uniform quantization. Let's assume, so if uniform quantization is done, then the step size will be VH minus VL divided by number of level. And before going into that, signal to quantization noise ratio is given by signal power divided by noise power, right? Signal power divided by noise power. So we are looking for the quantization noise power. Signal power we have calculated as 18, and signal to quantization noise ratio is given as 60. So we want 60 at least, right? So yes, Sunil, thank you so much, and wish you all the very best, and wishing you, in fact, happy Dhanteras and happy Diwali. And thank you so much for your YT content, comment. Oh shit. So we want signal to quantization noise ratio to be greater than or equal to what? 60 dB. No? Yeah, 60 dB. So it is nothing but the signal power. Signal power divided by noise power is greater than 60 dB. So the signal power is 18. So noise power should be less than equal to signal power divided by 60 dB. Okay, so we can also write 18 upon 10 to the power 6. Okay, when we divide it by 6, and yes, we will get this. So quantization noise power is given by delta square by 12. It should be less than equal to 18 upon 10 to the power 6. And we are expecting VH minus VL because we are considering the uniform quantization. So from here, well, I can say, yeah, yes, I am writing here. So VH minus VL whole square divided by L square. Okay, this is the delta square into 1 upon 12 less than equal to 18 upon 10 to the power 6. The maximum value of the message signal, it is saying that never exceeds 6. The maximum value never exceeds 6. So maximum value is 6. So minimum value can also be taken as 6, right? So 6 minus of minus 6 square divided by L square into 1 upon 12 should be less than equal to 10 to the power 6. Now this is 6 plus 6, 12. So 12 square is 144 and divided by 12 is again 140, 12 square is, yeah, again it is 12. Okay, so it is 12. So L square should be greater than equal to 10 to the power 6 into 12 divided by 18. So I can say that it is 2 into 10 to the power 6 divided by 3. So let me write L should be greater than equal to what? And we have to take the root also. 2 into 10 to the power 6 divided by 3. 816 we are getting. 816.5. So number of quantization level should be greater than. So what should be the number of bit? Actually, it is incorrectly written in the question. How many quantization levels are required to guarantee 60 dB? So the number of levels. Next, obviously, we will take the in the terms of 2 to power. So the number of level will be 1024. So to represent the 1024, the 10 bits will be required. So this answer will be 10 bits or the quantization level if you want to write then 1024. That is the answer. Okay, and it is also saying that what will be the bandwidth? Assuming the approximate bandwidth is W, then what is the minimum bandwidth required? So bandwidth required would be, bandwidth is nothing but N into Fm, Rb by 2, NFS upon 2, so N into Fm, so this is 10 into Fm. So the bandwidth requirement will be 10W. So the bandwidth is 10W. That is the second part of this question. 10W. Okay, got it? Moving into the next question. This is the next part of the question. Giving you again 5 minutes to solve. 6 minutes, 2 minutes for each part. Yes, you have 3 minutes more. A memoryless source emits 2000 binary symbols per second. Each symbol has a probability of 0.25 to be equal to 1 and 0.75 to equal to 0. Each symbol has a probability of 1 by 4 to be equal to 1 and 0.75 to be equal to 0. So 3 by 4 and 1 by 4 is the probability of 1 and 0, and as 2000 symbols we are transmitting. So what would be the entropy, and then you need to calculate the bit error, probability of error, right? What is the minimum number of bit per second required for error-free transmission? Error-free transmission is required. The second part and third part is not required because it is uh, something which you might not be knowing. Rate is given, then what will be the best strategy or in this case, or this what could be the way to solve this type of problem. Yes, now the time is over. See, there are two symbols having the probability, so the entropy we can calculate. We have the formula for the entropy minus summation I equal to 1 to m, suppose, then the probability of xi log base 2 probability of xi. So we have got the two probabilities. One is 3 by 4 log base 2 3 by 4 and 1 by 4 log base 2 1 by 4. So what is the answer? So 3 by 4 log base 2 3 by 4 and 1 by 4 log base 2 1 by 4. We are getting 0.81. Okay. Now we want to calculate the error-free transmission. So first of all, we will calculate the bit rate. Bit rate is R into H of X, the rate at by which it is the symbols are generating. So the rate by which the symbols are generating is 2000 symbols per second. 2000 symbols per second into 0.811. So you are getting 1622.5. This is the bit rate. Now for error-free transmission, what is the condition? For error-free transmission, okay, for error-free transmission, the channel capacity should be greater than RB. Okay, so it is saying that the minimum bit rate required, minimum bit rate for error-free transmission is this only, greater than greater than 162 22.5. It should be greater than 1622.5. So that is what this condition has to be satisfied. So the bit rate should be at least of 1623 minimum. Minimum is 1623. Now coming to the second part of the question. Second part of the question says we want to calculate the reproduction. So the reproduction 0 and minimum of p comma 1 minus p, whatever will be the minimum. Okay, the rate which is 0.25. Okay, the minimum of this is 0.25. So the d is in between 0 to 0.25. So the rate distortion function for binary memoryless source is the rate distortion function for binary memoryless source is HBP minus HBD. Okay, HBP is 0.811 we calculated and HBD is 0.1. For 0.1 is the 1 minus P. Okay, we will write HB 0.25 and HB 0.1. It is 0.811 which we had calculated for binary and HB 0.1, and this HB 0.1 is from here it is because why we are considering 0.1 because not exceeding the 0.1 it is saying. So 0.4690 from the table 0.4690, and when we subtract it 0.342 we will get. So 0.342 we will get, and then we need to multiply it again bit rate to calculate R into 0.342. That means you have to multiply it with the 2000, you will get 684. So 684 kbps would be the right answer for this question. And similarly, in the next question, you can take the instead of the 0.1, if you take the 0.25, you will get the right answer. Okay. Now coming to the next question, which is okay, this. Now at least answer this question. This one is easy compared to the last one. Here we have the seven symbols and all the seven probabilities are given. We have to find the first entropy. So entropy is easy. We can directly calculate. Now you have to think of calculating the entropy of the quantized source. After quantization, what will be the entropy? That you have to calculate. This one is easy, guys. At least you should be able to solve this type of question at this point of time if you are preparing for GATE really. Last 1 minute, and also this would be the last question. So a memorial source has a alphabet -5, -3, -1, 0, 1, 3, and 5 with the corresponding probability 0.05, 0.1, 0.1, 0.15, 0.05, 0.25, and 0.3. Find the entropy of the source. And then the question is that assuming that the source is quantized according to the quantization rule, that -5 is quantized. Yes. -5 and -3 has the value which is -4, -1, -0, and 1 is quantized to 0, and 3 and 5 is quantized to 4. Then in that case, what would be the entropy of the source? Yes. So let's solve this question as it is given the probability. So entropy is easy to calculate. The entropy can be calculated directly. In the first part of this question, the entropy of the source, suppose A, okay, entropy of the source A is the probability. So minus 0.05 log base to 0.05, it is coming two times, 0.05 and 0.05. So I am multiplying it by 2. Okay, this is not inside the log, right? Plus 0.1 is also 2 times. So I am writing now in this way. So 2 times 0.1 log base to 0.1 plus 0.15 is coming only one time. So 0.15 log base to 0.15 and 0.25 log base to 0.25 and 0.3 log base to 0.3. So after calculating this, what we are getting, let's Let's calculate. 2 into 0.05 log base 2 0.05 plus 2 into zero point 0.1 log base 2.1 plus 0.15 log base 2.15 plus 0.25 log base 2.25 plus zero point 0.3 log base 2.3. We are getting 2.528. Okay, so 2.528 would be the right answer for this. Now, in the second question, what we are saying is minus 5 and minus 3. The minus 5 and minus 3 is having minus 4. So, what is the probability of minus 4? The probability of minus 4 will be addition of probability of minus 5 and minus 3 because they are mapped to the minus 4. So, what is the probability of minus 5? It is 0.05. What is the probability of minus 3? It is 0.1. So, what is the probability of 0. Minus 4 is 0.15. Now, the probability of 0. So, probability of 0 is minus 1, 0 and 1. So, minus 1, 0 and 1. So, that means these three probability we need to add. So, probability of minus 1 plus probability of 0 plus probability of 1, it is 0.1 plus 0.15 plus 0.05. So, it should be 0.30. So, it should be 0.55 only. Yes. So, now the probability of 4 is summation of probability of 3 and probability of 4, which is 0.25 plus 0.3. We are getting 0.55. So, now we have the three probabilities. So, probability of 0 is 0.30. Probability of 4 is 0.55 and probability of minus 4 is 0.15. So now we want to calculate the entropy, then it is minus 0.30 log base 2 0.30 plus 0.55 log base 2 0.55 plus 0.15 log base 2 0.15. Okay, so let's calculate this. 0.3 log base 2.3 plus 0.55 log base 2.55 plus 0.15 log base 2.15, 1.406, 1.406. So as it is observed, the quantization decreases the entropy of the source, right? Because previously the value was 2.528 and here it is now 1.406. So quantization decreases entropy of the source. Okay, quantization decreases entropy of the source. Okay, guys, so now we are done with problems. All the problems we have almost covered that for which was for today. So this is for your homework. Okay, this is your homework. That consider the two 8-point QAM signal and constellation diagram is shown. The minimum distance between two adjacent symbol, this symbol is 2a. Here also it is 2a and here also this distance is 2a. I'm giving you a hint. The diagram is like this 2a. Okay, then you have to calculate the average transmitted power for each constellation and assuming that the signal points are equiprobable. So which constellation is more efficient? So solve this question and comment in the comment section that which one has the more, which constellation is having more efficient. So this is also I am keeping as a homework. So if you are watching this then comment these two questions, answer of these two questions. And yes, I want to tell you that if you are looking for the free content, then you can download our Byju's Exam Prep app. The link is given in the description. In the app, you will get the leaderboard facility, you will get the poll facility. We create the question, we give you the poll, you can answer in the form of four options. Then you will see the leaderboard that how many students are above you and how you are doing in the quizzes. And for Gate 25, we have launched the batch, so you can join our Gate 25 batch. And this is the team which we are having. And yes, this number you can contact, and you can take the detail of all the part of the syllabus and the related query, fees, etc., scholarship, discount, etc. Everything is available there. So don't forget to join my Telegram group if you want to connect with me. Thank you for watching this session, and I would like to have a break from you and wish you all happy Diwali. Those who are joining late, I'm sorry that I have another class, so I have to leave. And yes, Ashish, thank you so much, and Divyesh, thank you, and yes, best wishes to all of you, those who are joining this. Happy Diwali to all of you, Ashish, Divyesh, Sunil, Bhupati, Takesh, everyone. Enjoy this festive season. We will meet in the next session on Thursday, that is after Diwali. Thank you so much.